Welcome to Talking Tuesday. I am your host, Fancy Quant, and today we are going to talk about future-proofing your career. So this podcast in general talks a lot about my career, quant careers, all these sorts of things, but this really applies to all careers here. And the piece of advice I'm going to give you is going to be probably the opposite advice that most people are going to give you on the internet or even experienced professionals. And that advice is going to be focus on the fundamentals. Do not focus on the new, trendy, shiny careers and skills out there. So let's just dive on into this from a historic perspective here. Let's rewind in my career, and I'll give you a little bit of an example of how this has played out for myself, how this has actually better prepared me and given me a lot more options and flexibility moving forward, whereas others have kind of pigeonholed themselves into really odd career selections, and then you kind of take the gamble. You hope the new thing turns out. Maybe it doesn't turn out, and we'll talk a little bit about that. So I'm going to rewind this here. I don't know how far back. Let's say back into probably about 2012, 2011, somewhere around there. In my last year or two here of undergrad, I went out, I got a finance degree, right? Wanted to work on Wall Street, and I found out essentially that traditional people in finance didn't do a lot of what I viewed as what Wall Street did. It turns out a lot of people did this newfangled thing called financial engineering, which wasn't that new. It had been going on and on and on back way before that. It was booming in 2007, 2008 with the financial crisis, and then it kind of died out and fizzled. But I realized I needed math, stats, computer science skills to really get my hands dirty, to really contribute on Wall Street, to really do what I viewed as something meaningful and valuable in a career here. And so I realized too that finance in itself was kind of dying out. And so I ended up going to graduate school at the University of Michigan here. And so this is kind of starting at the basics. I had some fundamental finance skills. I knew I needed some math, stats, and computer science. I needed to go out and get a master's, and I thought getting a very specialized degree, being financial engineering, would essentially sign this nice fancy piece of paper for me, and then I would go in and become a financial engineer. And of course, naively, I didn't even realize, 2012, 2011, financial engineering essentially had died out after the 2007, 2008 financial crisis. So derivative pricing around derivatives, exotic options and all that falls into what's true financial engineering, which is a small subset of the broader field of quantitative finance, which I didn't even know or understand at the time. So I went to the University of Michigan for my graduate degree, and I got into the financial engineering program, and I was really excited. And I learned, took some financial engineering classes at the beginning. So I took the first semester of essentially a 1.5 to 2 year program. And of course, they pushed you to do a 1.5 years. And so I crammed in 6 courses in a master's program in the first semester, which I don't advise, as most real masters, academic masters, you take 3 to 4 classes per semester. But I dove into this, and I took a financial engineering, so continuous time and discrete time for stochastic calculus, which is a math class. I took that class. I took a statistical finance class, which was awesome. And then I took some other, classes on, can't remember the classes these days, but there are things on derivative pricing from a business perspective, capital markets, fixed incomes, these sorts of things. And I went through this program, and I was really unhappy with the way it was structured. So the program at the time, which no longer exists, there's a new one that was created, was torn between the business school and engineering. And LS&A didn't care so much, I guess, but it was the engineering school and the business school that were fighting it out, where engineering is saying these students need to take more math, more stats, more rigor, and the business school saying you need to take more and more and more finance. And I looked at it and thinking this is very shaky. There doesn't seem to be a lot of focus with this. And then on top of that, I started realizing I didn't like the way the classes were being taught. I didn't it was kind of high level. Let's skip through things. There's a lot of hand waviness going on in general, which a lot of you will find with master's programs. And that's when I started thinking I need to understand this inside and out. I need to understand every single piece of this. And so I'm looking at the curriculum as well, and it's great. There's a bunch of business classes. And after my first semester, I realized I don't need to take any finance or business classes. I already have an undergrad in finance. The MBA versions are essentially the exact same thing as your undergrad. So, that's kind of like, I don't want to do that. I want to focus more on math and stats, but I need to graduate this program. And I'm really struggling with the stochastic calculus class that I took, and I'm missing, some of the underlayers of mathematics, but I did enough to just scrape by, pass the class, and I moved on. But I wasn't satisfied. I wasn't happy. And I talked to these students in the program that were taking as well that were, doing stellar. And it was like, Dimitri, just memorize, memorize, memorize. You memorize this formula, you memorize that formula. And then you do all this memorization and you just, regurgitate them on exams and apply it to similar problems. This wasn't good enough, guys. I didn't like this. I needed to go back and I needed to learn the fundamentals. And as I looked at the curriculum, they were also missing like econometrics. In my mind, I'm starting to think like you're going to need to model things that are economically driven. The financial statistics course I took, or stats for finance, whatever, I loved the class. I really found it useful and interesting. And I started connecting the dots on how this would be applied. And I started realizing financial engineering was too niche, too focused. I really wanted to learn a lot more about it. And that was kind of my original intention, was going down that financial engineering path. But I started realizing more and more I needed more of these fundamentals to really absorb this and to really do fancier, more in-depth things here. And so I went back and I figured out, okay, the program's in shambles. I don't like not knowing every nuanced detail possible. And so what I ended up doing is deciding, okay, I'm going to pull out of the financial engineering masters, right? I could have just toughed it out, went through the grind, finished out the master's degree, which is more than possible, but I wouldn't have really understood everything that I wanted to understand. I wouldn't be getting the value out of the master's that I wanted to be getting. Sure, I would get the master's degree, the little slip of paper with my name on it, the university name on it. I could plunk it down for an interview, but it's just not good enough. It's not really teaching me what I need to teach. And so I looked at different programs, and University of Michigan also had a master's in applied economics, which was like a hodgepodge master's of, there's 5 courses, everything else is an elective, which fit perfectly for me in the sense that I could add in my financial engineering class that I already took as electives. I talked to the program. They were more than rigorous enough to meet that program. The 5 core courses, some of them were like econometrics, micro, macro, but coming at it more from a math perspective. So I'm like, okay, this is going to help, support my math side a little bit better. This is going to help build out, my statistics skills, doing econometrics. And then I still have some freedom to take some other classes that I want to take. And so at this point, I really focused on building my math, stats, and computer science, but doing it more at my pace, really trying to understand the ins, the outs, how things worked. I didn't care so much about let's take this really complex course or this really, too fast of a class in derivative pricing, because you really need a bunch of background to do it, and the program wasn't teaching it. And so I graduated the University of Michigan with a fairly strong background in statistics. Yes, my math, it's okay. I'm not a mathematician by any stretch of the imagination, but I understand enough. I can read the math and I kind of get through things with it, and I use it where I need it. And then my programming side, it's about the same as usual. I was coding before I went into grad school, been coding afterwards, so I'm comfortable with it. But I'm no software engineer that's going to go out there and build out some video game and do all that sort of stuff. And so I took my first job working in banking. So I couldn't find a job, as many of you know. I struggled. I had this weird resume where I had work experience. I had investment, corporate finance experience on there, which I was trying to apply to investment banking jobs. And then I had this financial engineering background. I had this quant background. I had stats background. I had an economics background. And I'm trying to hodgepodge all this together. And I really figured out I love stats. And so I built my resume completely around statistics, traditional statistics and econometrics. And I landed my first job working in banking. And I was on implementation at the time, but I started to work there, and I'm getting involved and I'm getting excited. And we're applying statistics to models here. And I remember the first big problem was a struggle with their models failing consistently over and over and over again. And of course, I went back and worked in time series, and I struggled with the problem with the rest of the team. And I came up with ideas on essentially how a lot of the assumptions were being broken and how we can fix them and make things better. And I was able to do that because I had a strong stats background, and I was able to take those core fundamental skills and go back to the textbooks I had, go back and look up academic papers, and try to figure out how things worked, why they were failing, and solve that problem. And I was able to work in model development after some time because it was like they were short staffed. They just need somebody to fit it. Clearly, I had the skills. But again, I didn't really have those skills in the sense of like I didn't have the experience in building models. I just had the fundamental core stats skills. Like in grad school, we didn't really spend time building models. Like they never said, okay, Dimitri, here's this economic trend or here's this financial data. Go out here and build a model for it. But I knew the basics. I understood the steps to go through to select a model, to do variable selection and all that. And so having those core fundamental skills was able to actually place me now into model development. So from implementation to development. And I worked that job for an entire year and I liked it, but I was really wanting to run with things. I was really wanting to do things that were more exciting, more creative, something more complex. Now, like my brain's starting to catch up somewhat from grad school. I'm like, okay, I kind of want to go back to the financial engineering side a little bit. And then an offer comes in, and it's to go work at BCG, which is Boston Consulting. And I consulted there for a little bit. 3 month stint. It was not the best experience, but I made it work. And again, at this job, I was working on a completely new area, which is going to be operational or operations research or operations risk here. So banks get, all kinds of weird issues that happens on the operations side. Like they might have a lawsuit pop up or they might have an employee screws up. And so it costs them a bunch of money. And they have these sorts of issues that kind of, pop up. And so they have to model all these and you don't have a lot of data for it. Completely new area of risk. So when I started, I was doing implementation and modeling in time series for CCAR, which is a very specific regulation. Then I'm jumping into this new role and it's like I'm just being thrown into operations research. And I'm like, oh, yeah, you could use this model, and this model. Now, I knew all these models because I do a lot of reading. But again, I had that background just in the fundamentals of modeling and stats and data. And so I was able to really pick that up and to really figure out like, oh, I can go into operations here. And then, of course, I could jump. I left there. I went to work at another bank, another global firm here. Try to avoid using the names of all the banks I've worked at. And I went to work there and they put me on like a little bit of mortgages and some retail banking accounts and, fairly simple things. But again, a completely new area, similar models, but different. And again, I had the solid background in math and stats, computer science. And so I was able to just jump into like this retail side and a little bit of commercial. But again, more now on a completely different side of quant finance and banking. And then I transferred from there to a different office and I ended up doing a bunch of credit modeling. And I did not have that much experience in credit modeling. And I spent, 6 years doing credit modeling. And this is a completely different set of models and a completely different business and different materials and different data. And again, I remember thinking like, oh man, I haven't looked at logistic regression in forever. And that's what they're telling me they're using. And, they're looking at like Logit or they're looking like at Tobit models, for example, and they're throwing out all these terms around loans. And at this point, it's been a couple of years since I'd even been in corporate finance or taken a class on loans and finance and all these sorts of things. But again, I had the background, I had the understanding, I had those core principles, and I could use those to go back to my textbooks, look things up quickly, or find a new textbook, or find, a new academic paper, something I had not seen, and just pick it up quickly because I could literally build from the ground up, and I could do it extremely fast. Okay, and we'll talk about this here in a second. But then I ended up moving on to another firm. Again, was okay here and there. Similar things, didn't learn too much, short stint again. And then finally now I'm in my new job and it is in fintech. So it's still like banking, it's still finance related, but now I'm kind of in this whirlwind of like a little bit of a new language. And now we're switching into, they need a model for this, they need a model for that. And since it's a smaller firm in fintech, right, these startups, you have to be able to cover even more areas of modeling. And again, I'm really excited because I'm like, oh man, I learned this model and I learned this model and I had these tools and I learned all these years ago. And again, I have never really used them in practice. So then you start looking online and you're reading and you're getting all caught up. And again, now it's like, oh, okay. And this is essentially the same problem, as like a different problem you've seen like in credit or operations. It's the same sorts of models, the same sorts of tools. You just start applying these across the board. And even one of my last jobs, I was teaching machine learning to a bunch of data scientists and correcting their work and showing them how it all works. And the big secret is, I'm not a data scientist. I didn't take data science classes. And I even remember back at the University of Michigan, being in the computer science building and seeing on the wall, like there was a degree in like data science or AI or something. And me being like, oh, that's so cool. Like, I really want to do that. But, I'm so busy with all these other classes. And yet now you look at my career, probably 6-7 years later, and now I'm actually teaching a material, data science and machine learning. And again, I was able to pick these things up extremely quickly because I had experience in the stats and the basics and understanding the fundamentals. And once you understand the fundamentals, it is far easier to build out and to go into all these new areas. And so one of the key, I think, aspects here is if you look at the radar since, I graduated here, in like 2011, 2012, and then going through time and going through my master's degree and all that, and then coming all the way up to 2022, big things have changed. Like fintech is a whole new area. Cryptocurrencies and DeFi is a whole new area. Machine learning and data science and ML engineers, that's a whole new area. And yet if you look at my career and you look at, Dimitri knows a lot about using machine learning in finance, and I've actually built out models for it, and I've validated models, and I've taught classes. And yet when you go through these, it's like, this doesn't seem feasible. Like it seems in your head, okay, you should have went into a data science degree, 3, 4, 5 years ago. When I was in grad school at Michigan, I should have seen the board that said AI and ML and stuff and been all jazzed up and quit and went and did that. And that's kind of the advice a lot of people are giving you is chase that new thing, chase that new skill. I would argue the opposite though. And the opposite is going to be building those fundamental skills, building a career around what you want to do here. So in my case for math, stats, computer science, I've built out this really unique set of skills in the sense that I can do quantitative finance. I can work on the trading and the buy side, for example. I have those skills. I can work in banking, so the sell side, building out, credit products. I can work in machine learning and data science, building automation tools, building models, for example, like decision trees and neural nets, and, doing all kinds of, cluster analysis, which again is all part of traditional stats as well. And the point here you start to see is I'm able to cover fintech. I'm able to cover machine learning and data science. And I've had, interviews, if you've watched this podcast as well, with some of the biggest names in tech, one of the FANG companies here. So building those fundamental skills builds maturity. And this is kind of the punchline, the thing I'm really excited to talk to you guys a little bit about. And unfortunately, it's taken me almost 21 minutes to get here. But Thomas Garrity is a professor. He's written a book called All the Math You Missed. I'm reading it now. I really enjoy it. I'll probably do a book review on it as well. But there's a video which I'll link at the end of this, or I'll put in the description below here on the podcast. And he talks about math maturity. And he talks about how in mathematics, there's this concept of maturity such that, the more mature you are, the quicker you can connect the dots. So meaning like math is somewhat, layer on layer on layer on layer. And then there gets to be a point where essentially math explodes. And there's all these ideas and all these concepts you've probably never seen or covered, even as a master's PhD professor. Even, Dr. Thomas Garrity here, he mentions in this video, which I'm talking about and I'll link at the end, that there's even topics like they hadn't seen, and they just don't venture down that because they're all researching on their own special topics here. And so I think this is kind of the first principles, the whole idea of this video here, which is building those first principles, building those skills from the ground up, and building really strong core fundamental skills. And if you can build those skills, you can build up your quant or STEM maturity here. Or if you work in some other field like medicine, you can build up your medical maturity. But essentially, it's far easier now for me to pick up a textbook and read it and figure out what's going on, figure out the assumptions, figure out the weaknesses, connect the dots, build the models, and then explain to other people why it works and why other people's models don't work and why this methodology is a better methodology, or to pick up new skills like machine learning and data science and AI and all that, or DeFi and crypto, which I have not worked in, but another venture, another future thing. But it's quickly, it's really quick for me to do that because I've built this somewhat level of maturity here. And now you can break these down even more into statistical maturity, mathematical maturity, computer science maturity, maybe say finance maturity. And my math maturity is not stellar. Like I wish that was far, far better, but on the quant spectrum, that is my weak point. And yet I still utilize that, right? Reading equations, reading textbooks, even on the statistics side, I need to be able to understand the equations and the math, understand how it works, and really work things out kind of in my mind and on paper here. So maturity and building fundamental skills, that's how you future-proof a career. You do not future-proof a career by chasing the really shiny thing. And it drives me nuts because I see people that say, oh, I'm really excited in data science and machine learning. I'm going to get a master's in it. And I'm like, awesome. That's a great plan. Like, thumbs up. But when you do that, make sure you really understand all the core fundamentals that are going into data science and machine learning behind the scenes. And a lot of that's going to be math, stats, and computer science. And again, you need to build out those fundamentals. If you build out those fundamentals, you might get a master's in data science, for example. Go out to get a job in data science. You might work that for a few years and then realize you want to do something different. Maybe you're going to go into DeFi or like the crypto realm, or maybe you want to go into like the buy side on investing for a bank. And yeah, they might need some data science skills, but they're going to need some other skills as well to do quantitative methods that are more focused on traditional statistics here. So building those core skills, that's how you future-proof a career. Even on the business side as well, the math side, the finance side, the other sides, the other industries out there, if you can build that level of maturity up, it's far easier to jump to new ventures. And I am really, really glad I didn't over-specialize. And I'm really glad I didn't finish my financial engineering master's, in the sense that I could have gotten a piece of paper. It could have, ran through it and said, I am a financial engineer. I have a master's in it. And yet I wouldn't have had those core fundamentals down as solidly as I should. And it would have been far harder for me career-wise to kind of jump between different venues and to kind of progress and do more and more exciting things and build out some awesome career, which I'm still working on to this day. So anyways, thanks for listening. Thanks for watching. And as always, until next time.